Hi guys, welcome to Unit 2, Lesson 3, Solve Multiplication Inequalities. Now, kind of like the last lesson, I don't really know why they only call it Solve Multiplication Inequalities because you do run into division as well, so just be aware of that. But once again, all of our integer rules still apply, and you still need to think about doing the opposite operation just like in equations, okay? So this first one, the way it's written, it almost looks like it could be a two-step equation, okay? And you can treat it like that if you want to. With this one, it says 5x over 9 is less than 8, okay? So, but with that, we could rewrite this to say 5/9 times x is less than 8. Technically, that's the same thing. So I'm going to show you both methods. You can choose which one makes the most sense to you. Okay? With this one, personally, I like the way this is set up more. With this, what I can do is I can say, okay, well right now, the whole thing, 5x, is being divided by 9. Well, the opposite of division is multiplication. So I could multiply both sides by 9 to cancel that out, because now I'm multiplying by 9 and dividing by 9, so those cancel, and I'm left with 5x is less than 72. Okay? Now, it's just down to like a one-step inequality. So I'm multiplying by 5. I need to do the opposite operation from that, which is division. So I could divide both sides of my inequality by 5. When you multiply and divide by the same number, those cancel, right? Because 5 over 5 is equal to 1. So really we're left with 1x on the left is less than. And then 72 divided by 5. Can you see that, hopefully? There we go. 72 divided by 5 is 14.4. So, x needs to be less than 14.4 in order for us to be able to plug something in and make that inequality true. Now, let's practice it the other way. So, I separated the fraction from my variable. So now I have 5/9 times x is less than 8. Well, multiplying, right, by something, the opposite of that is division. So I could divide both sides by 5/9. And we could write the whole thing out if you want. Divide by 5/9. But remember, when you divide by a fraction, it's the same thing as multiplying by the reciprocal. So I could do all of this, or instead, if I'm multiplying by the reciprocal, that means I'm multiplying both sides by 9 over 5. Multiply both sides by 9 over 5. Well, look at that. That's pretty much what we did over here already, right? So 9 times 5 is 45. 5 times 9 is 45. That gives me 45 over 45, which equals 1, or they cancel out. So on the left, I'm left with x is less than. Now, I can put my 8 over 1 to make it a fraction as well. That way I can multiply straight across. Well, 8 times 9, that's 72. 1 times 5 is 5. Well, look at that. We're right back to this part here. And that's one reason why I don't really see a need to separate them, but I did want you to see both methods. And then we know from before, 72 divided by 5 is 14.4. So, whichever method works best for you, you go ahead and choose it. Okay? Okay, moving on. This one we won't do twice. Number 2, 7 9/10 times x is less than or equal to 0. Alright? I kind of love this one because of that 0. Well, if we're going to think about the problem, right now we're multiplying by 7.9. So to get rid of it, I need to divide by 7.9. Okay? 7.9 divided by 7.9 is 1, so we're left with x or 1x over on the left. Symbol stays the same. And then 0 divided by 7.9. If you're like, it's too early for this, right? 0 divided by 7.9 is 0, right? If you have 0 Skittles and you divide them up into 7.9 groups, well, you still have 0 Skittles, right? So, just the answer is 0. Okay? So, x has to be anything less than or equal to 0 to make the inequality true. So, all right. With this next one, this is one from your quick check. This is number 3 on your quick check. I'm sorry, I'm getting to the end of my notebook, so it doesn't lay as flat as easily as it usually does. This time we're going to solve and graph. So right now, I am multiplying by 4. So to get rid of it, right, with the goal of having the x alone on the left, I'm going to divide both sides by 4. These ones will cancel on the left, and we're left with x is greater than, oh look, finally a greater than symbol. That's helpful. Okay, and then we have 10 divided by 4. That gives us 2.5, or 2 5/10. Okay, so now that we've solved all operations within our inequality, we can graph. So I know that I need the 2.5 on my number line. Okay, so I have a tendency to just, whatever this number is, that's what I put in the middle of my number line. You don't have to do that. It's fine as long as it's somewhere on there. So then we could say, let's see, we could say that this is 3, 3.5, 4, 4.5, however you want to list this. That would be 2, 1.5, 1, 0.5, 0. That kind of worked out nicely. So whatever this number is, that's where your circle goes. Remember from the last unit, or the last lesson, we talked about those circles. So 2.5, that tells me this is where my graph starts. Okay? I am not going to color it in because it's only a greater than symbol. It's not greater than or equal to. So what that tells me is, yes, my graph starts at 2.5, but I'm not including 2.5. I can't color it in and count it as a number that fits this inequality. Then, since my x is on my left, I'm set up to use our little trick where my greater than symbol looks like this end of the number line, so that's the direction that my arrow needs to face as well. And think about it, x is greater than 2.5, well, any number that's greater than 2.5 is going to be to the right. So that's where my arrow needs to face. And again, you can make it as long as you want, just as long as it's really obvious that that's where you're headed. And we put the arrow on the end to say, like, this keeps going. It goes on for a very long time. I just don't have the time or the space to write it, right? So, all right, guys, I hope that helps. If you need more, you just reach out to me, and I'm happy to help.